Welcome to the Grade 5 Dive-In 5 for dividing decimals. My name is Barbara Knox.
And I'm Daryl Frost. Welcome.
So your first task is on the next slide. You're going to pause the video and work either on your own or with a team, or maybe just with one of your teammates. While you're working through this task, I want you to reflect, just like we did with our last Dive-In 5, why is it important for students to use estimation when they're solving decimal division problems this time? We'll see you back in a few minutes. So looking at the progression of BEST, in fourth grade, they worked with looking at how the values of digits changed as it moved one place to the left or right, whereas in fifth grade, they're doing the same thing but looking one or more places to the left or right for a movement. They did do division in fourth grade with up to 4-digit dividends by 1-digit divisors. And they've also worked with fractions with denominators of 10 and 100 and how we can turn those into decimals. This year, new to fourth grade, they were working with addition and subtraction of multi-digit numbers with decimals.
That's new. Yeah.
That was new in fourth grade this year. So this year's fifth graders may not come with that understanding, but next year they will. And in fifth grade, we've also worked with reading, writing, and comparing decimal numbers to the thousandths place. In this unit, we are going to be working on these last two benchmarks. They are working only to the hundredths place in fifth grade with division. So I can divide a multi-digit number with decimals to the hundredths using estimation, rounding, and place value, where that last benchmark is dividing by 1/10 and 1/100th.
So I'm looking here and just looking at those last two benchmarks, which this Dive-In 5 is focusing on. I'm seeing strategy in that first purple benchmark there. You know, you needed a estimation as a strategy,
yes,
place value as a strategy, and also thinking about rounding.
Correct.
So those are, we really need to think about those things when we're facilitating lessons surrounding those benchmarks.
Yes. Thank you for adding that, Daryl. So because we are only dividing by tenths and hundredths, we can use the flat as our whole in this unit. So we'll be using the flat as one whole, the rod as 1/10, and the unit as 1/100th.
Makes sense?
Here you see 1 4/10 divided by 1/10. Daryl, what does that mean?
Well, I believe what that expression is really asking is how many 1/10 size pieces are in the dividend of 1 whole and 4/10.
You're absolutely correct. So the first thing I'm going to need to do is break that whole into tenths.
Sure.
So that I can count the total number of tenths. And when I count all of these tenths, how many of them are there?
There's 14 1/10 size pieces.
So my quotient would be 14. Here we have a very similar problem, but instead of dividing by 1/10, this time we are dividing by 1/100th. So again, Daryl, what is this problem asking?
Well, it's like the structure of division, which connects to our MTRs. It's asking how many 1/100th size pieces are in 1 whole and 4/10. So I'm going to need to decompose that model there into hundredths and count and see how many there are.
So I'm going to have to decompose that whole into 100 pieces and divide
and the rods into hundredths as well.
Correct. So when I do that,
there they are.
I know that on the left I have how many of them?
I've got 100.
And on the right, I have
40.
40 of them because my 4 tenths each separated into 10 hundredths, giving me 40 hundredths.
So, well, just a thought here. So it'd really be important too in the discussion and facilitation of when you have decimals is to talk about the structure of division. I still have a dividend, I still have a divisor, and I'm looking for a quotient.
Correct. Now my quotient here is going to be the total number of 1/100th size pieces that it took to make 1 4/10.
Which explains why it's a whole number, because the model shows that.
And when I count all of those, I have 140 of them, which is my quotient. So working with concrete tools, we're going to shift into the other benchmark where we are dividing by decimal numbers that are not 1/10 and 1/100th. Here I see 4 8/10 divided by 1 2/10. So again, Daryl, my thinking needs to be...
I'm still determining how many 1 2/10 are in my dividend 4 8/10.
So I want to then divide this into groups of 1 2/10.
Yes.
Yes, so here's one group of 1 2/10, two groups of 1 2/10, three groups of 1 2/10, and four groups of 1 2/10. So my quotient would be?
It would be 4.
4, because I have 4 of those groups.
So Barbara, just a thought here in terms of instructional practice. As a 5th grade teacher, I really need to be using these base 10 blocks to build these models. Otherwise, students are just kind of going to be blown away to think, wait a minute, how do I have a whole number as a quotient if we're not using that language of just like in 6 divided by 2, how many 2s are in 6? I'm asking the same thing here.
Correct. And I really need to use those concrete tools to build that understanding before I start working with the representational models.
I see it here.
So now we're going to work with a representational model. I'm taking pictures of those flats. So I have on the slide, I can see 4 holes. I only need to model 2 94 hundredths, because that's what I am dividing. So I model my 2 94 hundredths, and I have to divide that into pieces that are the size of 21 hundredths.
So I'm just essentially then decomposing that 2 94 hundredths, and I could shade over how many groups of 21 hundredths are in that dividend.
So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those groups that I was able to make.
Which is the quotient.
Which is the quotient. All right, this one might be a little bit trickier. We're going to first model our dividend, which is 3 75 hundredths. So I'm going to shade that in on my model. And our divisor
is 3/10, so it's asking how many 3/10 are in 3 75 hundredths.
So let's start shading those 3/10. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Uh-oh. I have some left.
Yeah, but it's
not 3/10.
But I have part of 3/10.
So I'm going to shade over the part that's left, and we're going to look to see how much of that 3/10 is shaded, Daryl.
Well, I can also connect 3/10 to 30 hundredths.
Correct.
Okay. So what I see shaded, when you went over it again, I see 15 hundredths, which would be half of the 30 hundredths. So that must mean I have half of the 3/10.
I can also kind of visualize that reddish section rotated.
Yes.
Where it would fit on top of the section that's entirely blue. So I had 12 whole groups of 3/10, and I also have half of a group of 3/10.
And I think that's what's really critical, is what you just said there. that 5/10 is half of the divisor, or the size of the group, 3/10.
Correct. So now I want to go back to the task that you worked on at the beginning of this presentation and thinking about what strategies they might have used and how estimation can come into play. Daryl, talk me through that first one, 6 divided by 48 hundredths.
Well, if I'm thinking about estimation or rounding, and I've worked with base 10 blocks, I know that 48 hundredths is about half.
Correct.
Or 5/10. So it's really asking how many halves are in 6? Well, there's 12. So
Right,
it's going to be around 12 as the quotient.
Because there are 2 halves in every whole, and I have 6 wholes. So
Yep.
I would have to multiply 6 times 2 to get my quotient.
Yes.
That next one, 3/10 divided by 1/100th, I want to think, well, every tenth could be separated into 10 hundredths. So if I have 3/10 and each one of them is 10 hundredths, I should have about 30, right?
30, yeah, exactly. You'd have 30 groups, about 30 groups of 100th.
Correct.
Yep.
What about 32 6/10 divided by 2/10?
So if I look at that dividend, and this is just how I see it, there's 32 wholes of
Correct.
something, right? Well, I know that in 2/10 I can visualize a flat. If the flat is the whole, there's 5 groups of 2/10 in one whole.
Exactly.
So I'm taking back to my understanding of base 10 blocks, the flat being a whole. Then if there's 5 groups of 2/10, I can multiply 32 times 5. That's 160. So my quotient's going to be around 160.
You're exactly right, Daryl. And our last one, 49 8/10 divided by 8 3/10. I can really round those both to whole numbers, and I want to think about compatibility. So 8 times something is going to give me something close to 49, and I know that 8 times 6 is 48.
Okay.
So I would probably change that 49 8/10 to 48 and divide it into 8 groups or into groups of 8, and I should have 6 of them. So my quotient should be close to 6. So just as a recap, you can see the different models for concrete thinking, representational thinking, and abstract thinking. Again, we want to move back and forth between these islands. By the time you get to that abstract thinking, they need to have had many, many, many experiences with the concrete models and the representational models.
Kind of like what I did with that flat when I was thinking about dividing 2/10. I think it was the dividend was 32.
So you're visualizing those models.
I could see that flat, and I could see 5 groups of 2/10 in that hole. Once I knew that, then I just multiplied it by the 32 holes.
So they need to be able to visualize those models in order to do the estimation that's required when we start working with decimal division using abstract thinking.
Exactly.
So thank you for joining us for this session of Dive in 5, Grade 5, Dividing Decimals. We'll see you next time.
Bye.